Hey guys, so remember it's that time of the day, it's our wild card question. Before we get into the question, I want to send a quick shout out to my boss Grant as well as Liberty. Guys, they're really doing a good job of sponsoring the show and we can't thank them enough. So guys, if you remember what a wild card is, a wild card question is basically a question that's off today's topic. Today's topic we're dealing with analytical geometry. Our wild card question is going to be something completely different. And it's just something to spice up the show a little bit, throw something in there, and you guys can always learn from these wildcards. It's great revision, especially going into your next month's exams, as well as your final. So the question today is from Monica. Let's have a look at what Monica has to ask us.
Monica here. Can you please help me with number 6, where I have to determine the values of A and B when I have a stationary point? And also how the format to determine the values of A and B in any kind of cubic function where I have my first derivative equation. Thank you.
Alright guys, okay, so as you can see, this question is not analytical, but it's based on calculus. You got 3 types of calculus that we deal with. We dealt with a few weeks ago on the show. We dealt with finding the equation of a cubic function, as well as first principles, and then also what we're going to be doing now, calculus graphs. Okay. Also, another thing I have to mention, Monica, you have just won yourself a 19-inch TV for sending in that question. Guys, it's as simple as that. You've just got to send in a question, make sure that we can see it nicely, give a shout out, give your name. Maybe show your face, take a little selfie over there with your WhatsApp camera and send us that video. So well done to Monica. Guys, let's have a look at what the question has to say. So we have the question that says f of x is equal to x cubed plus ax squared plus bx. And it says that it has a stationary point at 2 and 32. And they want us to determine the values of a and b. Okay. So guys, this is another typical exam question. There was another part to Monica's question asking, what do I do to determine stationary points when a line is perpendicular or when I get given other points? How do I go about it? So what we have over here, I'm going to draw us a little diagram and it says the following. At my stationary point, I'm going to have a gradient which is going to be equal to 0. So that means if I have my first derivative function, I can equate it to 0. Because that tells me at that point my gradient is equal to 0. That's going to be a factor we're going to use to try and solve for my A and my B. So let's have a look at what we're going to do first. I'm going to draw a little diagram over here for us. So what we have over there, we can see we've got some cubic function ax squared plus bx. I'm going to have a cubic function and it tells me that I've got a stationary point at 2 and 32. Now my stationary points are going to be either over there or over here. Those are my 2 stationary points if I have a cubic function. I'm just going to call one of them 2 and 32. I'm going to say this is going to be 2 and 32. That point over there can be anything else. Now what they're asking is that they want us to find the values of A and the values of B. So we have 2 values that we need to find. We need to find A and we need to find B. In order to do this, we're going to have to find 2 equations. And that's the only way we can then solve a simultaneous equation to find my value of A and my value of B. My first equation that I'm going to find is going to be when I substitute in my stationary point. The other equation, remember that fact that I told you, my first derivative is equal to 0, and I then have that equation equated to 0. And those are going to be my 2 equations that I'm going to find to try and solve for A and B. So let's have a look at what my first equation is going to be. I'm going to have that f of x, I don't like blue, I'm going to write this in black. Okay, so I'm going to have f of x is equal to, I just want to get this down for us, x cubed plus ax squared plus bx. X cubed plus ax squared plus bx. And I get given this point 2 and 32. So at this point when x is equal to 2, I can equate this to 32. So I'm going to say 32 is equal to 2 squared plus a multiplied by 2 squared plus b multiplied by 2. Now if I just simplify this equation a little bit more, I'm going to get 32 is equal to 4 plus 4a plus 2b. If I take this a little bit further, I'm going to be left with 32 minus 4. That's going to get me 28, if I'm not mistaken. 28. And that's going to be equal to 4a plus 2b. Okay. Hey guys, so at this point in time, I've got one equation. What I want to do is now, remember, I want to find another equation. I've got one equation, but I need two variables that I've got to solve for. So my other equation, I'm going to then find the derivative and equate it to 0 because it is a stationary point that I'm looking for. So if I have to find that, let's move my color now. Now I can use B. So if I have to find f prime of x, it is going to be equal to, I'm using my differentiation rules. It's going to be equal to 2x plus 2ax, and that's going to be plus bx. Let me have a look, plus b. And guys, in doing so, I've just realized that my value over here must actually be 2 cubed. So that's going to be 4. My bad. So that must be 2 cubed. That must be cubed because that was the equation that was given to us. That changes to 8. And then this part over here, 32 minus 8, is going to get me 24. That's a bit better. Okay. So back to this part of my equation. I'm now going to substitute in my value for 2, or my value for x, which is equal to 2. And I'm going to equate this to 0 because at x equals 2, I have a stationary point. Remember, guys, at that point, my equation or my gradient at my stationary point is 0, so I can equate it to 0. So substituting all of those values in, I'm going to get 0 is equal to 4 plus 4a plus b. I'm going to call this equation number 2. Okay, so let's have a look so far. So we've got equation 1 and equation 2. And what I'm going to do is now, is I'm just going to simplify this equation a little bit more over here. So what I want to do, actually guys, I just realized now, because I used my wrong equation in my first one, that all of this over here is incorrect. Let me try this again. Okay. So I now have x cubed. I was busy differentiating x squared. Sorry about this, guys. So f prime of x is equal to 3x squared plus 2ax plus b. Now if I substitute in my values correctly this time, I'm still going to have 0 is equal to 3 multiplied by 2 squared plus 2a multiplied by 2 plus b. Okay, so now we're back on track. I'm going to get 0 is equal to, that'll be 2 squared, which is going to give me 4 times 3, which is going to get me 12 plus 4a plus b. I'm then going to have minus 12 is equal to 4a plus b. Okay, sorry about that, guys. Little things that we need to correct. Okay, so that can happen in an exam. Just pay attention and make sure that you differentiate in your right equation. And when you copy down an equation, don't do what I did, copy it down correctly. Okay, otherwise you're going to get big errors like I've just done now. But everything's fine. We're back on track. We've now got 2 equations. We can now solve for my 2 variables by doing a simultaneous equation. So let's have a look at how we're going to go about that. We're going to have the following. Equation 1, we can say that, well, we can use this equation. And from equation 1, we can find b. So if I say then from equation 1, I'm going to have 12 is equal to 2a plus b. So I'm just dividing by 2. I'm then going to have 12 minus 2a is equal to b. And I'm going to substitute this into equation number 2. So what I'm going to have is negative 12 is equal to 4a. And my value that I just found for b is going to be plus 12 minus 2a. Now you can see I've got one variable in my equation. I can now simply solve for this variable because it's a linear equation, and then I can substitute that value into my other equation to find my b value. So if I carry on with this, I'm going to end up with negative 12 minus 12 gets me negative 24. 4a minus 2a is equal to 2a, and therefore I have a is equal to negative 12. Okay, so that's halfway done. If I want to find b, I just substitute in my value for a. So a is negative 12. Let me use a different color over here. I'm going to have then that b is equal to 12 minus 2 times negative 12. And that there, that's going to get me to equal to 36. And there we go, guys. That's my value of a and b. Okay, so I hope that helps you. It's a nice equation, or it's a nice question that always pops up in the exams, solving for those a's and b's. And we can use our properties of calculus to help us over there. And guys, don't you remember, don't make those silly errors in your exams. They are very costly. Okay, we're going to go now to our last ad break, and then we're going to be back answering another analytical geometry question. Stay tuned, guys.